Okay, on number 3 on this homework set, drawing a picture is worth 1,000 words in this one, so we can see what's going on. They say a rectangle is inscribed with its base on the x-axis, so it's sitting on the x-axis. And its upper corners are on the parabola 9 minus x squared. So first I just graphed 9 minus x squared, notice some stuff about it, like its max height here is 9, and it has x-intercepts at 3 and -3. And inscribed means that it's written inside of it, kind of like this. And then what are the dimensions of such a rectangle with greatest possible area? So we want this space to be as big as possible. All right, so notice we need to come up with something, right? Because area is length times width for this rectangle to describe its length and width. So if we focus on these corner points, notice like if this one, so how do I get an XY point? However far over I go here, then 9 minus x squared is how far up I am, right? Because I stay on this parabola. So whether I'm here or here or here, either way my y value comes from this. And same thing on the other side. If I put in negative x, I'll be at 9 minus negative x squared, but the squared cancels the negative anyways. Notice these 2 points have the same height. All right, so it looks like this rectangle always has a height, the distance from here to here, of 9 minus x squared. And then the width, how far is it from x to negative x? Because notice this thing is symmetrical around the x-axis. So if I go x units this way and x units this way, it looks like my width is 2x. Like for example, if I went 2 units that way, I'd go -2. So the width is 2x. And so if I want to come up with a function for the area, or you can just write the word area, totally up to you. I'm just using capital A to stand for it. The area of this rectangle that we're trying to maximize is width times height, so 2x times 9 minus x squared. And then like always, if I'm trying to maximize or minimize something, I want to take the first derivative and set it equal to 0. And they want to know both the width and the height. We're going to come out with x first, and we'll have to put them back in here to figure out the width and the height. All right, so probably the easiest if I distribute this in here. That way I have separate terms to take the derivative of. So 18x minus 2x to the third. And so the derivative of that is 18 minus 6x squared. And so now I want to set that equal to 0. I could factor a 6 out of both of those, which would leave me with what? 3 minus x squared. 18 and 6 have 6 in common. And so then if I divide both sides by 6, it gets rid of that, right? But it still keeps the other side as 0. And then I could add x squared to the other side. So x squared equals 3, so my two answers are plus and minus square root of 3. And obviously, if I'm picking x here, even if I do negative square root of 3 this way, I'd do positive square root of 3 in the other direction, so it probably makes sense to go with the positive one. All right, so then their question, though, is what width and height does that give us? So if we figure out our maximum is happening at square root of 3, then our width is 2 square root of 3. Or if you want to write it as a decimal, it's like approximately 3.464. And then our height is, if I put square root of 3 in here for x, square root of 3 squared cancels, so it'll be 9 minus 3, so 6. So we want a height of 6 units and a width of 2 square root of 3. So once you have the drawing, it's a little faster than it looks.